Okay, so I have here the oddly shaped pool, and essentially what I've done is just kind of written in the information that we were given in the problem. And the information we were given is the height or the width of the pool and the fact that these widths were taken at 2 meter intervals. Okay, so the first thing we're going to do is we're actually going to kind of orient this problem with an axis, an x-axis and a y-axis. Because if we want to find the area, that is a perfect time to start integrating. Okay? And the areas kind of, it doesn't really matter how the areas are arranged, right? So for instance, we could take this area here and move it down. We're not really changing the area. We could take the area and, move it over here. Do you see kind of what because this area is something we can kind of control and rearrange, as we want. And I did that before a little bit with the example of the trapezoids. Because what we said was, hey, look, if I have a trapezoid, that's the same thing as having command copy, paste. The same thing as having two trapezoids is the same thing as having a rectangle. So I was just messing around with the shifting those areas, moving those areas, and then we could rotate this, right? Maybe resize or something. Well, not resize because that's going to mess with the area. But we could rotate it, right, and get that. We can move area around in a way that's to make it convenient for us. So that's what we're going to do here with this little problem. So the first information we've been given is that in terms of data points, we have a sample of data taken every 2 meters. So let's see here. So up here we're just going to do the width of the pool. Now at the starting point, the width is 0 because it's the very tip. And then every 2 units, 2, 4, 6, 8, 10, 12. So 2, 4, 6, 8, 10, 12, 14, 16. 14, 16. Okay, so over here, 16 units away from this beginning point, we're also going to be back to a width of 0. Now, here we're at a width of 2. So that should be 2. And in fact, the longest this is 7.2, so I'm just going to actually go ahead and do 2, 4, 6, 8. So we'll have 1 at 2. 2 units out, we've got a 6.2. So we'll just do something like this to indicate 6.2, then 7.2. Put that a little higher, 6.8. Ooh, a little lower. I think I'm not doing a good job here. That was horrible. Okay. Just so we can have a really neat picture here. And let me put in a different color. Okay. So this first one here is going to be 6.2. Then this one is going to be 7.2. So let me erase it so it's not so high. This one's going to be 7.2, so it should be a little bit higher. And then this next one is going to be 6.8. 6.8. Maybe this 6.2 needs to be lower. So 6.2. 6.8, 5.6. So that should be dramatically lower. 5.6. And then a 5.0. 5.0. You know what would actually be better? If we just add a page below, and the page is going to have squared paper. Won't that save us all some time and stress? All right. So now, each mark, so let's see if I can do this. So each one is going to be 2. So it'll be 2, 4, 6, 8, 10, 12, 14, 16. Okay. 16, 14, 12, 10, 8, 6, 4, 2, 0. And then in terms of height, let's go 1, 2, 3, 4, 5, 6, 7, 8. So it's 8, 7, 6, 5, 4, 3, 2, 1. Okay, and the data we have is we've got the points 0, 0, 2, 6.2, 2, 7.2. Do you see where I'm getting these points from? No. So it should be 4, 7.2, right? Because then over 4, and then up 7.2, over 6, up 6.8, 8, 5.6, 10, 5.0, 12, 4.8, 14, 2.0. Let me copy these, paste them here, and let's go ahead and get started. Okay. So I've got my 0, 0, 2, 6.2. That's going to be my 6.2. 4, 7.2. 7.2. 6, 6.8. 6.8. 8, 5.6. 5.6. 10, 5.0. 5.0. 12, 4.8. 4.8. 14, 2.0. 2.0. And then, of course, 16, 0. So we're back to 0. So here's the idea. The idea is that the area of the surface of the pool is the same as the area underneath these little points. Okay, if we just kind of take these points and shift them around, kind of shift them up and down vertically, that'll give us the shape of that pool. Now, to estimate this area, since we're using Simpsons rule, we're going to need to form parabolas. Okay, so the first parabola is going to be something like this. Second parabola is going to be, between these 3. The third parabola is going to be with these 3. And the fourth parabola looks like it's coming in like that. Okay. So for the purposes of our formulas, what is our formula going to look like? First of all, what is N? What is A? What is B? And what is our f of x? Well, N is going to be, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. N is going to be equal to 8. A is going to be 0. B is going to be 16. And our f of x is, we don't have a formula for f of x. It's going to come from the data. So this comes from the data. So what is our delta x? Delta x is the length of each subpartition, and that's going to be 2, right? So we're going from 0 to 2, 2 to 4. Delta x is going to equal 2. So our formula for S8 is going to be delta x over 3 times, now we need f of x1, or let's see if we start off with f of x1 or if we start off with f of x naught. F of x naught, sorry. So it's going to be f of x naught. Let me get my coefficients in order, actually. So I want to have, I don't want to write too big because I want this to stay neat. So I would like f of x naught 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then f of x 8. And then I need a 4 for f of x1 and a 4 times f of x7. And then 2 times, my pen is way too thick. Okay, let's try this over. Let's try it again. So I've got f of x naught. Oh, this is much better. And then f of x 8. 4 times f of x1. Okay, 4 times f of x7. 2 times f of x2, right? Because I need 1, 1, 4, 4, 2, 2, 4, 4, 2, 2. Okay? And then it's f of x naught, f of x1, f of x2, f of x3, f of x4, f of x5, f of x6, f of x7. F of x8. We have to stop at f of x8, so that's why for me it's really best for me to just really start, like work my way in. So if we have f of x8, okay, f of x1 and f of x7, f of x2 and f of x6, f of x3 and f of x5. And then in the middle, we'll have f of x4. Good. So we don't need one of these 2's. We're going to turn that into a 2. So now, what is f of x naught? Well, let's come up with a list. So x naught is 0. x1 is 2. x2 is 2. X is 4. x3 is 6. x4, 8. x5, 10. x6, 12. x7, 14. x8, 16. So remember, it's like A is always x naught and B is always xn. So we're right on track with what we would expect. So what is f of x naught? That's just going to be 0. What's f of x1? So 2 units in, what do we have? 6.2. 6.2, and then 7.2, and then 6.8, and then 5.6, and then 5.0, 4.8, 2.0, and then we're back to 0. Okay, so now we need to multiply this coefficient times this value, this coefficient, this value, right? So multiply the coefficients times the values, and we'll get 1 times 0 is 0, which makes sense because you're not adding any area from that. You know, if your height is 0, you're not adding any area to your integral. And then 4 times 6.2 will be 24.8. And then 2 times 7.2 is going to be 14.4. And then 4 times 6.8 is going to be, it'll be 24, 25, 26, 27, 27.2. And then 2 times 5.6 will give me 11.2. 4 times 5 is going to be 20. 2 times 4.8 is going to be 8, 9.6. 4 times 2 is going to be 8. And 1 times 0 is going to be 0. So now I add all of these up. And then I'm going to multiply them by my delta x over 3. What is delta x? Is 2. So 2/3. And that is my S8. Okay. So I don't know. Let me see if I can add this up right quick. So we've got 24.8 plus 14.4 plus 27.2 plus 11.2 plus 20 plus 9.6 plus 8. Okay, let me just double check here. 11.2, 20, 9.6, 8. Okay, so I got 115.2. And now this needs to be multiplied by 2/3. We get 230.4 over 3. Got 76.8. Now let me talk a little bit about the units. What would we expect the units to be? Because it's area, we would expect the units to be meters squared. Meters squared. Now how do we get meters squared out of this? What are the units on f of x naught, f of x1? These are all, right, these are all meters. This is in meters, right? Because these are the heights. The height of our function, which is the same thing as the width of the pool. So that's in meters. So if we add a bunch of meters up, we're going to just get a whole bunch more meters. But now what about this 2/3? This 2, which is the delta x is talking about the width of each subinterval. So this is in meters. So now we've got meters over here, meters over here. So at this point, we're working with meters squared, and that's how we get meters squared as our units. So our units do add up. That's it.